Good morning to everybody. Myself, Professor Pushpa N. Avanti. In today's video, I am going to discussing about the topic cardinal points. In the cardinal points, I am explaining about expression for Newton's formula. So, before going to start this derivation, just I have to give the glimpses about the terminology. That is a basic terminology of the optics. There is a lens, and lens is nothing but it is an image forming device. A lens is made up of glass and is bounded by two curved surfaces or by one spherical surface and a plane surface. So there are two types of the lens, convex lens and concave lens, and also there are thin and thick lenses. And the focal length, the definition of the focal length, principal focus, optic center, and also the principal axis. See here in this class, now I will explain about the Newton's formula. See, the Newton's formula, before going to Newton's formula, we have to know about the Lensmaker's formula. Lensmaker's formula is nothing but it is a 1 by f is equals to mu minus 1 into 1 by r1 minus 1 by r2. Mu is the refractive index. R1 and R2 are the radii of curvature of the lens, and f is the focal length of the lens. So the Lensmaker formula tells the lens maker what is needed to know to grind a lens at a given power. So the refractive index of the glass and the two radii of curvature. Now we obtain a lens equation for the practical applications. It relates the focal length to the object and the image distance, and this is also known as lens user's formula or Newton's lens equation. See here in this figure, here we have to consider the lens. The C is nothing but it is the optic center of the lens, and O is the object, I is the image, and F1 is the focal length of the object to the optic center, and F2 is the focal length of the optic center to the image, and here U is the object distance, V is the image distance, and D is nothing but it is the distance between the object and the image. And x1 is the center of the object from the optic center, and x2 is the distance between the optical center and the image distance. See here, if x1 and x2 are the object distance and the image distance, then the equation of this is given by 1 by x1 plus 1 by x2 is equals to 1 by f. X1 is the distance between the object and the focus, f1 on the object side as shown in figure above, and x2 is the distance between the image and the focus, f2 on the image side. So if the distance of the object and the image are not measured from optical center but from first and second principal foci respectively, then Newton's formula states F1 F2 is equals to x1 x2, where x1 is nothing but it is f1o, x1 equals to f1o, that is distance of object from first focus f1, and x2 is equals to f2i, distance of image from second focus. Therefore, f2 is equals to minus f1 is equals to f. If medium on either side of the lens is same, means both the side the medium is same, then f2 is equals to minus f1 is equals to f. So Newton's formula takes the form x1 into x2 is equals to f square. So here the x1 x2 is equals to f square is the Newton's formula. The last states that the product of distances of object and image from respective foci is equals to the product of focal lengths, that is the half lenses, and the Gaussian form of lens equation is that is 1 by v minus 1 by u is equals to 1 by f. So here u is negative and V and F are positive, then M equals to V by U, where M is nothing but it is the magnification of lens. Magnification of lens is defined as it is the ratio of the image distance to the object distance, that is F by x1 is equals to minus x2 by F. So here the the terms x1 and x2 are extrafocal object and image distances respectively. They are measured from the foci rather than from the lens. Consequently, Newton's equation can be used both thin as well as the thick lenses. Therefore, when the medium is the same on both sides of the lens, then the Newton's formula becomes x1 x2 is equals to f square. So in the Gaussian formula, the object and image distance are measured from the lens center, while in the Newton's formula they are measured from focal points. So this is about the expression for the Newton formula. The Newton's formula is given by, that is, f x1 into x2 is equals to f square. Thank you.